Hit record. All right, everybody. So 8.3 is on simple interest. The formula we use for simple interest is I equals to PRT. When we talk about simple interest, everyone, simple interest is interest which is earned. It's earned only on the principal, as in your initial investment. Now I'm talking about initial investment. It could also refer to a loan. When we talk about a loan, like a car loan is given out in simple interest only. All right. So the first thing I need to talk about are those variables in there, guys. So the variables are consistent throughout this chapter. So whenever you see I stands for interest. P, whenever you see P stands for the principal. Principal could be how much you invested, how much you borrowed. So whenever you see P has to do with the starting amount, the initial amount. R is your rate, and when we talk about rate is always given as a percent, and so you want to convert that to a decimal. Next, we got time. Time, guys, the unit of measurement for time is year. So if it's not given to you in year increments, you need to go ahead and convert it, okay? So let's say you were to go down the boulevard and deposit $2,000 into a savings account, guys, all right? And the first question would be, what's my interest rate on the savings account where I'm depositing $2,000? Right now, guys, the interest rates on these bank accounts are really, really low. By the way, guys, remember this is the consumer chapter. So this is where we learn things about your finances. In this case, we're talking about simple interest, but in the next section, we're going to be talking about compound interest. So guys, the rate at some of these banks right now is a whopping 0.01%. This is nothing. So in other words, if you were to deposit $1,000 into a bank account, at the end of the year, you would make 10 cents. 10 cents, as in 0.10. So if it's 2,000, you would make 20 cents. That's how bad the interest rate is right now, okay? So guys, let's carry on. So let's say you find a bank that gives you a generous 2%. And you're going to leave this money in there for 3 years. You don't need the money for 3 years. So the question is, how much interest will you earn on this money at the end of the 3 years? So you would take your principal, which is 2,000, and you multiply it by the interest rate. By the way, guys, here's the formula again. I equals to P times R times T. So the principal is 2,000. We're going to multiply it by the interest rate. Now, the interest rate is 2%, but as a decimal, it will become 0.02, all right? And you guys are going to need your calculators too, and then you multiply it by the time. So if you were to go ahead and grab your calculator, I don't even see my calculator right now. What happened to my calculator, Shazam? Okay, I normally have a calculator on my workstation here, but I can't find mine, guys. Yeah, I always like to have it. Oh, there's my calculator. All right. So guys, let's go ahead and throw this on a calculator. 2,000 times 0.02 multiplied by 3. So the outcome is $120, everybody. So at the end of the 3 years, you would earn $120 in interest. So I am going to erase this and move on to the next part of it, guys. So at the end of the 3 year, how much is your account value? What's your account value? You started with $2,000, okay? And then you earn $120 in interest. So you got your principal and then plus your interest, and that will give you your account value, your accumulated value. So this account has accumulated to $2,120 in the 3 years. Now, I can hear some of you right now. You're probably saying, oh my God, that's nothing. In 3 years, whoa, that's nothing. So guys, this is what's happening with some of these accounts you have, like your savings account. Most of you probably have a savings account that's paying you about 0.03%. Some of you, if you go online, you might get a better interest rate. There's this website called www.bankrate.com where you can go and search information about any of these banks in the US. Now, what does it do for you? It gives you information about all the different accounts they hold and the interest rate. They compare interest rate. They tell you which banks has the best interest rates and so forth and so on. So guys, if you're looking for a competitive rate on your savings account, you might have to go to an online bank. And one of the places you should go to check things out is at bankrate.com. By the way, I'm not advertising for bankrate.com. I'm just sharing information with you guys. Some of the best online banks right now are Ally, Capital One, 360. I feel like there was one more, but I can't. Oh, Navy Federal. I think you have to have some kind of relationship with somebody in the military in order to get the best, in order to be a member of this bank. Don't quote me on that, okay? So these are some of the better online banks. And with the online banks, guys, why do you want to do online? Because you get a better interest rate on your money since they don't have brick and mortar to pay bills and overhead on, okay? So I just needed to say that to you guys. By the way, I love talking about money. So yes, if you are annoyed by that, please let me know so I don't talk about money, okay? So guys, the total account value was $2,120, okay? So now, another way to calculate this is to use future value. Now, future value, guys, the formula is A equals to P times 1 plus RT. Now, for this one right here, what you have to understand is this, guys. Future value is nothing more than this. This is what it is, guys. Future value is the amount, okay? Hold on a second. Let me go ahead and grab my pen here. We got the amount we invested, the principal, which represents P. And then we have the interest. How do we calculate the interest? We go ahead and use the formula I equals to PRT. Shazam, I'm writing the wrong thing. PRT, that's what I want to write. Okay, so guys, what you will notice is that there's a P here and there's another P here. I'm going to use that F word and factor out the P. So if I factor out the P, what do I have left over? P divided by P, that's 1. PRT divided by P gives me RT. So this is where the future value formula comes from. So guys, what am I trying to tell you? I'm trying to tell you this. You can use this formula right here to come up with this value right there. So let's go ahead and try the formula. So remember, we started with a principal of $2,000 at a rate of 2%. And we had the money invested for 3 years, okay? And so the question is, what will be the accumulated value or the future value of this account, guys, in 3 years? The future value of the account in 3 years. So here we go. We go ahead and substitute the 2,000. We substitute the 0.02, that's the interest rate, which we convert into a decimal, and then substitute the time, and then work it out. Just plug it into a calculator. And yes, this will give you $2,120. So guys, here are your first 2 formulas for this chapter. The interest formula plus the future value formula. So you might want to make sure you write these down somewhere, or if you have an index card that you plan on using. Personally, I wouldn't use an index card, but hey, that's just me. I would write my list of formulas on a piece of paper and have them right there. And then additionally, what I want to recommend to you guys is to write down any side notes that's going to help you with the formula so you know how to utilize the formula. All right, everybody. I am going to do a couple of examples here. So here comes the first example. Now, the first example is this, guys. P is equal to 4,000. R is equal to 8.25%. And then this money will be in the account for, let me see here, 2 years. So the question is, how much interest will you earn on this account after 2 years? To calculate how much interest you've earned, you're going to use the formula I equals to P times R times T. So we're going to do, here we go. I is equal to 4,000 times, guys, be careful with the interest rate. The interest rate is 8.25%. As a decimal, it would be 0.825, okay? 0.825. And then the length of time is 2. Now, you grab your calculator and throw this on the calculator, 4,000. Make sure you guys have your calculators with you so you can practice, so that when it's time for the test, you know exactly what you're doing with your calculators, guys. And of course, you have your calculators on the cell phone, on the computer. You can use those too, okay? Ooh, I made a mistake here, guys. I didn't put the 0 here, okay? I left out my 0. So that threw off my number there. It's $660, guys. That's how much interest we've earned. Now, if they wanted us to find the future value for this one, let me write it on the side. The future value for this particular problem, if you're looking for your future value, it would simply be A equals the principal, which is 4,000. And then plus the interest you earn $660 in interest. So the future value would be $4,660. In other words, guys, if you go back into this account in 2 years, your account should have $4,660 if the interest is simple interest. And that's it. Okay, now remember, if you have questions, guys, you can go ahead and drop it in the chat, or you could go ahead and just turn on your mic and ask me the questions, okay? So here comes a secondary example, guys. This second example here is P equals to $3,000. You are investing this money at 6.5% for 3 years, and your job is to go ahead and calculate, find the future value, calculate the future value. So guys, remember, the future value is nothing more than the principal plus interest. Or you can use the direct formula, A equals to P times 1 plus RT. Now, depending on who you are, some of you are very comfortable with this formula right here, but some of you prefer to calculate the interest and then add the principal. So it's up to you. It really doesn't matter. You still get the same answer. So I'm going to actually use the future value formula. I'm going to plug in the 3,000 for P. Then I am going to substitute the 0.065 for the interest, and the time is 3 years. So I'm going to throw this into my calculator, guys, and let the calculator do it for me. Make sure you type the parentheses in there, everybody. So it's 3,000, open parentheses, 1 plus 0.065 times 3. And then you want to go ahead and close the parentheses and hit enter. Excuse me. So here, the total account value is $3,585, guys. Any questions? All right. So here's the next one, guys. Let's see. Actually, let me go to compound interest. Hold on, guys. Guys, I'm sorry about that. My dog is making too much noise out there and I'm getting a tickle in my throat. So here we go, guys. Compound interest is next. Now, normally when I'm in the classroom, I like to share the story at the beginning of lesson 8.3. So I think I'm talking about the wrong group of Native Americans here. You guys can correct me if I'm wrong, okay? So in 1624, okay, the Native Americans sold Manhattan Island for $24, guys. $24. And that's not the bad part about this story. The worst part about this story is that if they had taken that $24 and put it into a bank account, basically the story says they would have over $5 billion in the account. So the question is, how would they manage to have over $5 billion in the account? That is through the power of compound interest. So the question some of you may be asking is, what in the world is compound interest? Let's go ahead and talk about compound interest, guys. So compound interest is simply this. This is where you not only earn interest on your principal, you're going to earn interest on the principal plus interest on any interest earned. So not only are you earning interest on the principal, but you're also earning interest on any interest you've earned. So that way your money grows faster. And when it comes to compounding the interest, guys, the more times the interest is compounded or calculated per year, the more you earn on your investment. So compound interest is a phenomenal thing. This is how most of your investment accounts are calculated, or they are invested. They are invested using compound interest. Now, what I'm going to do is give you a third formula right here, guys, and then I'm going to explain it to you. So here's your compound interest formula. A equals to P times 1 plus R over N to the NT power. Now, I want you to analyze this formula right here. What I want you to notice is this, guys. The variables are still the same. P, principal, R is rate, T is time, A, of course, is the amount, the accumulated value, the account value is still the same thing. The only difference is the N. N is the number of times the interest is calculated or compounded per year. Calculated or compounded per year. So once again, guys, the interest here, the N value is the number of times the interest is calculated or compounded per year. So the interest could be calculated annually. And if it is calculated annually or compounded annually, the N value becomes 1. And if N is 1, you go into the formula, guys, all these N values become 1. That formula is going to simplify to A equals to P times 1 plus R to the T power. So essentially, when you plug in 1 in here for N, R divided by 1 becomes R. And 1 times T becomes T. So whenever the interest is compounded annually, N becomes 1, so the formula simplifies out. So if you have a list of formula you're keeping track of, this is one I would go ahead and write on my list, and next to it, I would go ahead and write down annually. I just realized for some reason I left out the A in annually, okay? So guys, I would write this down. So this simplified version is better than the original version if you are compounding the interest annually. Furthermore, guys, the interest could be compounded semi-annually. Here, let me finish erasing all of this here, okay, because I didn't want to erase the formula as well. So, all right, there we go. The interest could be compounded semi-annually. And if the interest is being compounded semi-annually, that's every 6 months. So the end value would be 2. The interest could be compounded quarterly. And if the interest is being compounded quarterly, the end value would be 4. There's monthly. If they are going to calculate the interest monthly, that means every single month. So the end value will be 12. And then last but not least, guys, they will do it on a daily basis. If they're going to do it on a daily basis, it's 365 times per year. And so on this one right here, guys, be careful, because in my math lab, remember, they didn't have all these powerful calculators, okay, when some of this was invented. So sometimes they will want you to use 360 because it's an easier number to deal with instead of 365. So make sure you're reading the directions and so you know what they want you to do. So the interest could be calculated annually, semi-annually, quarterly, monthly, and daily. By the way, the more times the interest is compounded per year, the more money you will earn. All right, Tinio, I see your hand. Go ahead, ask me a question.
Yes, I had a question. So you said that sometimes it will be 365 or 360. How do we know which one? Like, what would it say to know?
The book will, not the book, my math lab will actually tell you to use 360 instead of 365. Yeah, the problem will say that. Normally, when I select the problems on the assignments, I try not to use the daily because there's a better way to compound the interest instead of daily. Because when you do daily, that's 365 times a year. You can do it the other way and do a better job with that. You know what? Let me just go ahead and tell you guys what it is, okay? The best way to compound interest is through interest compounded, guys, continuously. Why am I putting this U here? Compounded continuously. When the interest is compounded continuously, there's no end value, as in they're calculating the interest all the time. So the formula we use when the interest is being compounded continuously is the PERT formula. A equals to P times E to the RT power. You don't need to put this dot over here, guys. Actually, you know what? Let me go ahead and take that dot out. The PERT formula. So it's P times E to the RT power. Now, E is very similar to pi. It's an irrational number representing 2.178. And so 2.718, 178, Shazam, what the heck? Okay, 2.718. 2.718, you think, I've done this so many times, okay? No. So guys, 2.718 is the value of E. Now, the beautiful thing is, you do not have to worry about memorizing this because E is on your calculator. For most of you on your calculator, you will see E looking something like this, E to the X, or perhaps E to a square, something like that. You can look above your LN key and you might be able to find your E value there. So look at your calculator, check your calculator, and your calculator will tell you guys which one it is, okay? What is after the P on E? Okay, yes, it is on E, absolutely. Okay, so guys, listen.
Oh, wait, I had a question.
Go ahead.
Sorry, so just so I make sure, so if we do compound continuously, we wouldn't, do we plug that in to this formula, or is that a separate formula entirely?
This is the formula specifically for interest compounded continuously.
Oh, okay.
So you wouldn't use the other formula. In order to use the other formula, it specifically has to say the interest is being compounded quarterly, monthly, daily, semi-annual. If it doesn't give you a number of times where it's compounded per year, okay, and it says it's compounded continuously, you have to use this formula right here.
Oh, okay. Thank you so much.
We are going to do examples, guys. All right. So, guys, let's go ahead and look at the $2,000 question from earlier. Remember that $2,000 question, guys, when we did it with simple interest, we had a total value of $2,120 in the account. So we're going to leave this to the side. Now, it's the same account, the same interest rate. The only difference is we're going to compound this. Now, the first way we're going to compound this is annually. And if we're going to compound it annually, the end value is going to be 1. So if we go into our large formula, P times 1 plus R over N to the NT power, this will be, okay, here we go. That's supposed to be on A there, guys. I don't know why it's not writing. A equals to 2,000. And guys, you need your calculator so you can practice. Parentheses 1 plus, oh, I forgot to mention this. Remember, guys, when it is compounded annually, the formula simplifies to just this. This is annually when the interest is compounded annually. So 1 plus the rate, 0.02, raise it to the number of years this account is being compounded. Guys, grab your calculator. Let's put it into the calculator. And the point for this problem right here is to make the comparison as to the difference between compound interest and simple interest, 0.02, and then raise it to the third power. Now, guys, if you need help with your calculator, let me know. Let me know if you need help. Your keystrokes on the calculator, okay? Let me know about it. Did you guys get this?
I have one question. On my calculator, I know like where I can do, you know, my x squared, but I can never figure out how to change it other than when it's squared.
Okay. Hold on to that thought. I will answer it for you later on. So once I'm done with the recording, you can actually put your camera on the screen so I can see what it looks like, so I can find that delta for you, or the power for you. Normally, okay, this is what you would have for your power keys. The delta, that's one option. Most calculators have this one.
Yeah, I have that.
Oh, okay. So once you do 2,000, open parentheses 1 plus 0.02, hit the delta, and it should allow you to type in the power. So you type in the third power and then hit enter.
Thank you.
Oh, there you go. Problem solved. Okay, perfect. So guys, let's make the comparison. Let's look, guys. This is how much is earned, okay, when the interest is just being compounded once a year, in comparison to when we had simple interest. This person has earned an extra $2.42. I know some of you are probably saying, well, wait a minute, that's not a lot of money. But here's how you need to think about it, guys. That's $2.42 you didn't have. What can you do with $2.42? Well, let's see. These days, you can go to McDonald's and buy 2 McChickens. You can buy 2 McDoubles. You can buy, for me, I like to think of gas, okay? I can buy some gas with this. Or I could take the $2 and drop it in the stock market. I know, okay? So guys, $2.42, it may not be that much money, but this is only on $2,000. So imagine if you had more money, okay? So now we're gonna try this again, guys. We're gonna change it to this time. The interest is going to be compounded monthly. Okay, let's go to monthly, okay? We're gonna compound the interest monthly. Now, notice I didn't do semi-annually. I didn't do quarterly 4 times a year. I'm going straight to monthly because I'm trying to expedite this, guys. So if it's monthly, N would equal to 12. So I'm gonna go into my formula right here, and I'm gonna do A equals to 2,000, parentheses 1 plus 0.02 divided by, notice I'm dividing it by the end value. The end value is 12. And then I'm going to raise it to the 12 times 3 power, because remember guys, it's n times t power. Now, additionally, let me say this to you guys, listen to this part right here. When you're doing these problems on the calculator, it's easier for you to do the multiplication ahead of time. So you do your 12 times 3, which gives you 36. So when you go and compute it, you want to input the 36 power, not 12 times 3, because some of the calculators are finicky depending on how you put in that 12 times 3. So it's easier to do the 12 times 3, get 36, and use the 36 power. So guys, again, if you've got your calculator next to you, practice putting these on the calculator, because it's really, really difficult to do these on the calculator when you're on the test, guys. So 2000, open parentheses, 1 plus 0.02 divided by 12, hit your power key and raise it to the 36 power, guys. So this is what I'm getting. $2,123.57. Did you guys get that? By the way, guys, when you are rounding, listen to this one. When you're rounding, be careful. Sometimes they will ask you to round to the nearest cents or the nearest hundredth, or they don't ask you to round at all. They don't tell you where to round, because you're dealing with money. Nearest cents, 2 decimal places. Nearest hundredth, 2 decimal places. If they tell you nothing, again, you're dealing with money, 2 decimal places, okay? Because you are dealing with money. So guys, now I want you to notice, simple interest, it was $2,120. And when we went to the annual, it went to $2,122, and I think it was like 54 cents. Now, with the interest being compounded monthly, you're up to $2,123.57. So if you compare that to the simple interest, guys, you just earn yourself an extra $3.57, okay? You can definitely get a gallon of premium gas for that. You can go ahead and get yourself a couple of hamburgers at McDonald's with this. So guys, every little bit helps. 10 pennies equals a dime, and 10 dimes equals $1, guys. That's how it works, okay? So the more times the interest is calculated or compounded per year, the more you earn on your investment. When you are finished with this section of the lesson, do you mind giving me the attendance code? Not sure if I missed it. Okay, I didn't give out the attendance code yet. I'm still recording. Once I'm done recording, I'll go ahead and take care of that. All right, guys. Now, guys, here's the next one. We're going to compound the interest continuously. When the interest is being compounded continuously, you want to use the PERT formula. And we're still doing the same scenario. The principal is $2,000. The interest rate is 2%. And the time is 3 years. So guys, let's go ahead and go into the formula. A equals to 2,000 times e to the 0.02 times 3. Now, for most of you, the e is located right above your ln key. So if it's above your ln key, you may have to hit the second key first, or shift, in order to access that. So guys, try practicing putting this into your calculator. 2,000 times e to the 0.02 times 3. Okay, by the way, when you hit E, the parentheses will show up automatically. So guys, here's the account value when the interest is being compounded continuously. And this is how you make the best return on your investment. When the interest is being calculated or compounded continuously. This is when you make the most money. Any questions, guys? Nothing? All right, everybody. So now let's go to the $5 billion question I mentioned earlier. So Manhattan Island was purchased from the Native Americans for $24. back in 1626. Now, oh, I forgot my number here. 1624, I think I told you guys, 1624. Okay, so if they had invested this money at a rate of 5%, guys, okay, until 2020, how much money would they have? So guys, first, we're going to take 2020 and subtract the 1624. Okay, so that's going to give us 396 years. And this interest is going to be compounded continuously. So guys, we're going to go into this formula right here. A equals to P times E to the RT power. Substitute the 24N, that's your principal. The rate is 0.05 times the number of years, 396. Now guys, try it. Plug it into your calculator. Let's see what you end up with. 24 times E to the 0.05 times 396, guys. All right. Oh, Shazam. Wait a minute now. Oh, I know why it's this much, because I didn't go to 2010. I think the example in the book is 2010. But my example right here, guys, here's the number. Here's the number. If we are doing it to today, it's 9533271,979. Every third digit, you want to put a comma. So guys, there it is. $9.5 billion. B with a B. Billion with a B, guys. That's how much they would have from that $24. You got 7.94. Oh, okay. All right. That's how much, guys, they would have in the account in 396 years. I know. You're not going to live that long, but your family, okay? Your children's, and so forth and so on, okay? You leave this legacy behind. This is where it would be at today, guys. So in essence, what are we saying about compound interest? This is one of the best inventions, guys. One of our great scientists said, compound interest is one of the best things ever invented. Yes. And through the power of compound interest, guys, you can grow your coins significantly. And then the other thing that many of you have going for you is time. So the earlier you start investing your money at compound interest, and we are going to look at some investment vehicles like a Roth IRA, the better it is for you. The more time you have on your side, the more money you will make. So time, guys, is another precious commodity. We don't know how much we have, but let me tell you, the earlier you start, the better it is for you. So guys, essentially, we just talked about simple interest and compound interest. I am going to be pausing the recording here so I can go ahead and go straight into the assignment and do some example problems with you guys there, because I'd rather do the example problems from the assignment instead of just doing random examples right here. If you guys want me to do a couple on here, I can. Do you guys want me to do a couple on the recording so you have them to look at?
Yeah.
Okay.
Yes, please.
All right. So here's one of the long problems that you will see when you go on the assignment. So let's say you are investing $10,000, guys, at a rate of 7%. And you're going to leave this money in here for, let's say, oh, I'm just making this up as I go along, 18 years. I'm making it up. I like 18 years because, some grandparents, when their grandchildren are born, they like to invest for their grandchild's education. So the child will have access to that money at 18 years. Okay, so that's why I'm using this example. So guys, this particular problem, I'm saying it's long because they're going to ask you to calculate the amount the account would have if the interest is being compounded annually, if the interest is being compounded quarterly, if the interest is being compounded monthly. And if the interest is being compounded continuously. So you have to do all 4 parts for this one problem, okay, continuously. And I'm running out of room here. Let me try and erase that. Shazam. I ran out of room there, guys. Okay, so let's try that one more time. Continuously. So on this one, let's go ahead and go into the formula. Annually, remember, n is equal to 1. So because n is equal to 1, you want to use the simplified version of the formula. And so A would equal to 10,000 times 1 plus 0.07. Remember to convert the interest rate to a decimal, and we're going to raise it to the 18th power. So guys, try plugging it into your calculator. Let's see what it says on your calculators, okay? 10,000, just like you see it, guys. 10,000, open parentheses, 1 plus 0.07, close off the parentheses, and then raise it to the 18th power, everyone. So this comes out to $33,799.32. Now, one of the questions, follow-up questions they could ask you to this problem is, how much interest was earned on this account? On this $10,000 investment, how much interest did this person earn? So to calculate the interest earned, you take the total accumulated value, A, and you subtract the principal, guys. So to calculate the interest, here, let me put an I here. No, let me go ahead and erase this part and I'll rewrite it for you guys, okay? So to calculate the interest, we take the amount, the total amount, we subtract what we initially invested, in this case, the principal. So in the case of this problem right here, guys, we started with, we ended up with $33,799.32. We started with 10,000. And so guys, look, how much money did we earn in interest? $23,799.32. That's a nice chunk of change in 18 years. Not bad at all. By the way, this is the average rate of return on the S&P 500, guys. That's why I use the 7%. Additionally, guys, let me just say this. There is a rule that we use to figure out how long it will take approximately for money to double. We call it the rule of 72. And so for the rule of 72, guys, all you do is take 72, divide, this is supposed to be a 7, divided by the interest rate, and now I'll tell you approximately how long it will take for the money to double. So 72 divided by 7 is what, 10 point something? We'll approximate it to 10, guys, okay? So yeah, 10.3, okay? So we're gonna approximate it to 10. So guys, every 10 years, this $10,000 would double. So if this money was invested when this child was born, okay, when the child is 10, the money would double to $20,000. If the child waits until he turns 20 to collect the money, at 20 years old, that money would double to $40,000. Shazam, okay? That's what we're talking about here, guys. The rule of 72 helps you to determine how long it's going to take for money to double. On average, guys, money doubles every 14 years on average, all right? So this is a great formula for you to know, the rule of 72. So that was part A. Now we're gonna move on to part B, and part B says, how much would you have in the account if the interest is compounded quarterly? So this time, because the interest is being compounded quarterly, we have an n value. The n value would be 4. We go into the formula that has the n value. And so we would go ahead and plug in these values for the variables, 10,000 for P, the 7% for R, 0.07 is the decimal, 4 for the n, and then we're going to raise it to the 4 times 18, guys. Now, let's go on the calculator and plug this into the calculator. And once again, everyone, you might want to do the 4 times 18 first before you plug it into the calculator. And 4 times 18 is 72. So rather than use the 4 times 18 when you're typing the problem in, use the 72. So give it a try. 10,000, open parentheses, 1 plus 0.07 divided by 4, close the parentheses, and then you are going to raise that to the 72 power, okay? All right, so I left something out. Okay, let's try this one more time. Let me see, 10,000, open parentheses, 1 plus 0.07 divided by 4, and then I am going to raise that to the 72nd power. And there we go, guys. Here we go. $34,872.10, guys. There we go. So, what do you notice? We've made a little bit more money. Yeah, before we were at 33,000, and now we're at 34,000, guys. We've made an extra $1,000 on this account. Yeah, okay? So now we're gonna go to the monthly. Now for the monthly, you don't have to change that much. So if you're on your calculator, you can actually go back and edit the information you plugged into the calculator. Just remove the 4, wherever you find a 4. Just go ahead and remove them and plug in the new values. What are the new values? Well, if it's monthly, n would equal to 12. So you're gonna plug in 12 over here and 12 over here. Like always, I like to do my calculation on the side before I plug it into the calculator. So 12 times 18 gives me 216. So that's the power I'm going to use, guys. So now I'm going to type this into the calculator. Remember, we're on the monthly. This is part C now. So we're gonna do our 10,000, open parentheses, 1 plus 0.07 divided by 12, close the parentheses, and we're going to raise it to the 216th power, everybody. So once you, ooh, Shazam, look at this money right here. So this one turns out to be $35,125 and how many cents? 39 cents, everybody. That's the monthly. So guys, what I want you to notice is, as we increase the end value, what seems to be with the amount you're earning on this account, the accumulated value of the account, it's increasing as well. So guys, what do you think is going to happen with D? D is where you make the most money. So D is going to turn out to be in our favor in terms of how much or the value of the account. So guys, remember, once you get to part D, you can no longer use this large formula. You have to go to the interest compounded continuously formula, AKA the PERT formula. So for this one right here, there's no end value. So on the PERT formula, guys, it's A equals to P times E raised to the RT power. So you get A equals to 10,000 times E to the 0.07 times 18 powered. And guys, notice I'm not computing the power here ahead of time. That's because once you hit the E value on your calculator, it is prompting you with an open parentheses so you can do the multiplication. It's expecting you to do that multiplication, the 0.07 times 18. So let's go ahead and plug it into the calculator, guys. 10,000 times E to the 0.07 times 18. All right. Now, this is going to turn out to be $35,254. $35,254. Hold on a second. $35,254.21, guys. This is where you make the most money, when the interest is being compounded continuously. All right, guys. So that's compound interest. By the way, I know some of you are probably saying, wait a minute, in 18 years, you mean to tell me we can't make more than 35,000? I can hear some of you right now, especially guys, since some of you just witnessed the power of the stock market during the pandemic. So for those of you saying, you know what, this wasn't enough money for me, is there a way to make more money? Absolutely. And we're going to be talking about it in this class too. And one of the ways for you to potentially, possibly make more money is to invest that money in some stocks. Great stocks, companies that you believe will always be around. And one of the companies that you know, guys, will always be around is, which one, guys? Which one is always going to be around? Come on, somebody knows this answer. Which company is a great stock to invest in that you know will always be around? Which one?
Google.
Okay, Google. Give me another one. Anybody?
Apple.
Yes, Tennille. Apple. Okay, I'm going to use Apple because I'm very familiar with Apple. And Apple is always affordable, guys. When I say Apple is affordable, as in they make the shares affordable. So let's say this child was born in 2002, everybody, 2002. You know what? Let me erase this because my pen is not writing there. I have a scratch on this iPad. Okay, so 2002 is when this child was born. So the grandparent decided to buy $10,000 worth of Apple. And I think, you guys can, don't quote me on this. I think Apple was trading at about $22 a share back in 2002. Somebody can go ahead and Google it for me. So if I take 10,000, guys, shazam, and I divide it by $22 a share, it would have produced about 455 shares. So this grandparent here would have purchased just Apple, guys, 455 shares. Shazam. Now, guys, get this. Apple, since 2002, has split, I think, 3 times or 4 times. I think I may have missed one of them, but let's say 3 times, okay? And it just recently split this year. I'm sure everybody heard about it. So the first time it split, okay, it split 4 ways. Was it 4 or 3? Oh, Shazam. Miss Alcira is messing up this problem. Okay. I have the information somewhere. I just don't remember exactly what it is. I think it's split 3 ways. I'll just go ahead and make it up, guys, as I go along. 3 ways. So your 455 shares will now become, let me see here, 455 times 3. That's going to become 1,365 shares. Okay. Now, the next time it split 7 ways. So that 1,365 shares, we're going to multiply it by 7. So now we have, oh my God, almost 10,000 shares. Guys, oh my God, 9,555 shares. Shazam. And guys, it just recently split 4 ways. So the 9,555 shares will now become 38,220 shares. Now, listen to this. The price of Apple today, I think, was about $108, but we'll make it a round number. Okay, Tania, I'll explain that to you in a minute, okay? So we're going to multiply it by 105, guys. Multiply it by $105 per share. Okay, everybody. So if we times this by $105 per share today, shazam, okay? Guys, this is not made up. This is possible. There are people who actually did this out there, and their grandkids are now sitting on a pile of cash. Let me show you how much this would have accumulated to. The accumulated value is, bam, Bam. Okay? As in 4 million, guys, with an M, 4 million, $13,100. Yes, way, Tennille. Yes, way. I've just been very curious lately about these things. I know, Tennille, I'm with you on that, okay? I have a lot of stories. I wish I could tell you guys these stories, but I don't want to keep you. Okay, yes. So I think you guys can see what I'm talking about. And that is one of the topics we discuss in this chapter, investing in the market. This doesn't always happen, guys, but it does happen from time to time. Now, one of the other stocks that has done really well since 2010 is Tesla. And there are a lot of people who became millionaires off Tesla recently, guys. You know what I'm talking about. Recently. So I am going to leave it here, guys. I'm going to turn off the recording so we can go ahead and have our little conversations, all right?